My final project is over the physics of throwing a baseball. The distance from where I threw the baseball to where it ended was 10 meters. The displacement is the same as distance, so it is also 10 meters. The reason it is the same as distance is because the ball travels in a straight line. Speed equals distance divided by time. Velocity is the speed of the ball and the direction it is moving. Therefore, the final velocity is 5 meters per second east. Momentum equals mass times velocity. The mass of the baseball is 0.145 kilograms. The final momentum of the baseball is 0.725 kilogram meters per second. Acceleration equals final velocity minus initial velocity divided by time. 5 divided by 2 equals 2.5, so the acceleration is 2.5 meters per second squared. The force of air is pushing the baseball down a little bit. The force of gravity is bringing the baseball down towards the earth. I apply force to the baseball, making it move towards my dad. The balance force is when the ball hits the glove because the net force equals 0. The unbalanced force is when the ball is thrown and is in midair. Friction occurs when my foot steps to throw the baseball. My foot slides along the cement, creating friction between my foot and the cement. Gravity pulls the baseball down towards the Earth's surface when the ball is in the air. Everything on Earth is affected by gravity. Also, gravity doesn't require the ball and the glove to have contact with each other. Weight equals mass times gravitational strength. The baseball weighs 0.145 kilograms and the gravitational strength on Earth is 9.8 newtons per kilogram. Therefore, the weight of the baseball is 1.42 newtons. Mass is the makeup of the baseball, while weight is the gravitational strength exerted on the baseball. Mass of the baseball is 0.145 kilograms. Newton's first law proves that when the baseball is at rest, it will stay at rest unless acted on by an unbalanced force such as me. This law is also known as the law of inertia. The baseball's mass multiplied by the acceleration when in midair is equal to the unbalanced force acting on the baseball. The human is the unbalanced force in this situation. The amount of force used by the human is 0.3625 newtons. Newton's third law applies to throwing a baseball because once you throw the ball, the wind is pushing an opposite force on it. Also, the other person catching the ball is an opposite reaction. This law states that every action has an equal and opposite reaction. Force equals mass times acceleration, so therefore the force equals 0.3625 newtons. Like I said earlier, the amount of force the human uses to throw the ball is 0.3625 newtons. Work equals force times distance. The amount of work needed to throw the ball is 3.625 joules of work. Power equals work divided by time. Work divided by time in this situation results in 1.81 watts of power to throw the ball. The equation for kinetic energy is 1/2 times mass times velocity squared. The amount of kinetic energy in this situation is 1.81 kilojoules. To find potential energy, I did the mass of the baseball times free fall acceleration times height. The potential energy is 2.842 kilojoules. Thanks for watching, and hopefully you learned something new about the physics of throwing a baseball.